Are you ready? So in electric circuit, are you with me? They are what we call circuit theorem. When you get to advanced classes for 200 level engineering students, there are different circuit theorem. And one of the circuit theorem is what? Kechhoff. There's what we call Thevenin's, 200 level first semester. There's Thevenin's, there's Norton. Yes, I think those are the most three aspects that we have. Thevenin's, Norton theorem, Kechhoff. There's still one more, but there are four. So that means Kechhoff is just part of the what? Circuit theorem we have. Are you with me? So today we are going to learn about Kechhoff circuit. So let's write. Kechhoff was discovered by a man named Gustav Kechhoff. Gustav Kechhoff. That's the name of the man that introduced Kechhoff circuit, or let me say Kechhoff theorem. Now the question is, why would this man bring up Kechhoff theorem? Initially, if you look at electric circuit, electric circuit should contain, let's say we have a resistor, we have a cell, no, we have ammeter. And pay attention, everybody. What's this, everybody? This is what? A cell. And a cell has two terminals, a positive terminal and a negative terminal. How do I know? The one that has a longer side is positive. The one with a shorter one is what? Negative. Now, what's this? This is a resistor. And this what? Ammeter. Are you with me? So, this is a simple circuit. Why is it a simple circuit? A simple circuit will always have, one power source and just one or two resistors. Are you with me? Imagine I have this kind of circuit now. One, two, three. Now, looking at this, is this a simple circuit? Can we call it a simple circuit? Are you sure? Are you sure? So why do we call this one a simple circuit? Because it doesn't have one resistor. So this one called three resistors is not a simple circuit. Now that's wrong. Okay, let's look at this. For this case, it has what? Resistor, cell, and what? Ammeter, isn't it? Ammeter is to measure the current. Sometimes you don't need to put it there. Sometimes you can put it there. It's not necessary. So now this one to ask what? A cell and what? Resistors. So should we call this a simple circuit? Now, how do you know a simple circuit and how do you know a complex circuit? Simple. This one, can't I resolve all these resistors as a single resistor? I can resolve it and still come back to this. So it's still a simple circuit. But when it comes to a situation whereby you have more than one cell, if you look at Kechhoff circuit very well, the one in your textbook or the one lecturer gave you or the one in your past question, you see that you'll be seeing current flowing up and down. You see current at this side, current at the other side, a lot of current around the circuit. So anytime you have a lot of current around the circuit, that means a lot of power source around the circuit, know that you're using what? Kechhoff law. So let's write. Kechhoff circuit is used or is identified when there are multiple cells in the circuit. When there are multiple cells in the circuit and resistor in the circuit. When there are multiple cells and resistor in the circuit, we call it Kechhoff circuit. When there are many cells, for instance, now you can be having this cell in the other one, like you can see one here. I think there's a branch now for this case now. So you can see a battery here or a cell. You can see another cell here. You can see another cell here. You can see resistor. You can see resistor. You can have resistor. You can have resistor. Look at this case now. How many cells do I have now? 1, 2, 3. How many resistors? 1, 2, 3, 4. So it's not the number of resistor, it's the number of what? Cell. So when your cell is getting more than 1, unlike this one, how many cells is there? Just 1. This is called a simple circuit. But when your cell is going beyond 1, like 1, 2, 3, in the circuit, is what? Kechhoff's law. Or you say what? Kechhoff's circuit. So let's write laws of Kechhoff's circuit. There are two major laws in Kechhoff's circuit, and probably you might be asked to state it in your exam. The first law is called Kechhoff's current law. Kechhoff's current law. In a short form, they say KCL. The other one is called Kechhoff's voltage law. In a short form, they say KVL. So let's pick it one after the other. Kechhoff's current law and Kechhoff's voltage law. Picking the first one. Kechhoff's current law. KCL. Right. So let's go, please. Kechhoff's current law. Like I said, the short form is KCL. And Kechhoff's voltage law, the short form is called KVL. So let's state Kechhoff's current law. Right. Kechhoff's current law states that at every T junction, the algebraic sum of the current that goes into the circuit is equal to the algebraic sum of the current that leaves the circuit. Again, it's very important. Kechhoff's current law states that the algebraic sum of current that goes into the circuit is equal to the algebraic sum of current that leaves the circuit. Kechhoff's current law states that the algebraic sum of current that goes into the circuit is equal to the algebraic sum of current that leaves the circuit. Okay, illustration please. Now let's assume we have this. A quick one. Can this be called a T junction? Okay, let me try this. Junction A, B, C, D, E, and F. Which of them is a T junction? Is A a T junction? How do you know it's a T junction? It will form letter T. So this form letter T. What of this? It's going to form something like this. What of C? What of F? What of E? It's going to form something like this. So what of D? So we ask you, how many T junctions do we have? 2. Is that clear? So there are T junction what? B and T junction what? E. So let's quickly. Let's assume we have a T junction. Let's call it T junction B, for instance. Then we have a current going this direction. We have another current coming this direction. Then we have another one going this direction. Let me call this I1, I2, then I3. Now look at this carefully. Where is your T junction? We have a T junction at B. From Kechhoff's current law, it states that the algebraic sum sigma of current, which is your I, that goes into the circuit is equal to the algebraic sum of current that leaves the circuit. Now let's look at the current that goes in. I1, is it entering the junction? Yes. By the arrow. I2, is it entering the junction? I3, is it entering the junction? Calm down. The arrow here is going this way. So it means that I1 is entering, isn't it? Plus, is I2 entering? Plus what? Is there anyone going out? 0. Okay, let's give another example. Please look at the board. Let's obey Kechhoff's current law. The algebraic sum of current that goes into the circuit is equal to the algebraic sum of current that goes or leaves the circuit. That goes out of the circuit or leaves the circuit. Now, looking at it, which of these current is going in? This is the T junction. This is the junction here. I1, is it going in? Yes. So it can form a T junction at any angle. You can form T junction from here. This place now can form a T junction. This place also can form T junction. Every aspect can form a T junction. Is that clear? So, in this case, I1, is it going in? I2, is it going in? I3, is it going in or out? So, I3 is going out. So, we are going to have it here. Are you with me? I3, I4, in or out? In. Plus I4. I5, in or out? Out. This is how you know. I3 is out? Okay, I1, I2, I4, they are going in. I3 and I5 are going out. Is that clear? Now, there's other way they can write this thing. Do you know we can also bring all to the other side by saying I1 plus I2, I3, I4 minus I3 minus I5 equals 0. Still the same thing. So that's what we call Kechhoff's current law. So let's go to the next one. Kechhoff's voltage law. Let's go. Kechhoff's what? Voltage law, right? We are there. Kechhoff's voltage law states that the algebraic sum of current, the algebraic sum of voltage at a closed path is equals to 0. The algebraic sum of voltage at a closed path is equals to 0. Now, mathematically, we can say algebraic sum of voltage is equals to 0. Now, please, in physics, when you have voltage can be written as V equals to what? IR. So that means I can replace this as saying algebraic sum of IR equals to 0. Are you with me? So what this means is that we can have V1 plus V2 plus V3, then Vn equals to 0. Is that clear? Yes. That means when you keep on adding the voltage, you end up having it as what? 0. That's voltage law. So before we start, we're going to learn some things now. Sometimes they also call it's also called the loop law. You don't want to call it Kechhoff's voltage law. It's also known as what? Loop law. Okay, should we go on? Now there are some elements, please write elements in a circuit. Now, what do I mean by saying element? Element refers to those things you will be seeing in your circuit. For instance, in Kechhoff's voltage law, there are two important elements you are going to be seeing. The first one is your battery. I'm calling it battery because that's what we are used to. Normally it's called what? Normally it's called what? A cell. Now, a battery is like this, please. A cell is like this. Are you with me? A battery is combination of two cells. Then this is what? A cell. Now, if you look at a battery, the last terminal of the battery is a longer line. So because it's long, we call it a positive terminal. While the one that is here is a short one. we call it a negative terminal. So what am I trying to say? In your exam, you might be seeing this diagram, and also you might be seeing this diagram. They're still meaning the same thing. It's just this one has two cells, while this one is just a single cell. So for this case, if this is long, you have to be what? Positive. If this is short, you have to be what? Negative. Is that clear? Now there's something we want to discuss here. There's what we call voltage drop and voltage gain. Voltage drop and voltage gain. It's under KVL. Pay attention. Let's assume I have my cell, and we know that this is positive and this is negative. Now pay attention. If your current, because in your Kechhoff circuit, they will always be showing you direction of current. Look at this. Where is the current going to? This direction. Let me put it as I. If your current is moving this direction, what does it mean? Looking at your cell, the current is coming down like this. So because it's coming down, it's called voltage drop. Hello? It's called what? So this is called voltage drop. But when it comes to a case whereby you have it the other way around, probably the current is coming like this. We have plus, then minus. The current is coming in the negative direction, the other direction. So it's coming this way. What's it doing? It's climbing. So as far as it's climbing, it's called voltage gain. Is that clear? And anytime we have a voltage drop, the summation of voltage is always negative. And anytime we have a voltage gain, the summation of voltage is always positive. Know that. For instance, let's assume they said the voltage gain was 5 volts. And you notice that when you were looking at the direction of current, it's coming this way. So that means what will be your summation of voltage? Minus what? Minus 5 volts. But let's assume here it's 5 volts, and we're told that the direction of the current is moving this way. So that means summation of voltage will be what? Plus 5 volts. Yes. From negative, this is what you're talking about. Yeah, from negative to positive is gaining. But from positive to negative is losing. Is that clear? So that's the first element we are discussing, which is battery or cell. The other element is called a resistor. Now, the diagram of a resistor can be in these two diagrams. You can have a resistor like this, or you can have it. Okay, my own is not okay. And look at it carefully. A resistor can be in two diagrams. It can be like this, or it can look like this. So in your diagram in the exam, they might give you this, it's still resistor. They might give you this, it's still resistor. Now, a good one, a question I would love to ask. Can a cell produce a current? A cell, can it produce a current? Yes. But can a resistor produce a current? No. And what you use the current to determine whether it is positive or what? Negative. Are you with me? Now, because of that, pay attention. A resistor does not have a current. We can't say here is positive. We can't say here is what? Negative. We can't say here is negative. We can't say here is what? Positive. There is no evidence. You can't choose anyone. So what we can do is that when we get to what I'm going to explain later on, there's what we call loop. Hello? Don't forget I said KVL is also known as what? Loop law. A loop is always in this way or this way. That means clockwise and what? Anti-clockwise. Are you with me? Now, let me use one example now. Let's assume my loop is what? Clockwise. This loop. If it is clockwise, and the direction of the current is like this, the loop and the what's it called now? The loop and the current, are they moving on the same direction? Are you with me? You use the loop and the current to determine whether it is positive or what? Negative. Now, if the loop and the current are moving on the same direction, it means that the summation of voltage will be negative IR. Same what? Direction. They will give you, see there, you see a diagram. No, you be the one to create your own loop. What they only give you, that they only help you to draw a current beside the resistor. I will show you. Let's go on. I said at that time, if your loop and your current are moving on the same direction, what's it going to be? Negative IR. But let's assume the current, this same loop, I'm using this one now. If the current is going like this, or let's use this side. This I1, let's call this I2. The current is going like this. Looking at the loop, are they on the same direction? They are opposite each other, isn't it? Now, due to because of that, we call it what? Positive IR, opposite direction. Now, we can now learn the Kechhoff's circuit diagram. So in that case, should I rub this side? A, B, C, D, E, F, G, H. Now pay attention. There's what we call mesh. Are you with me? Now, you remember when I was stating current, Kechhoff voltage law, I said, I didn't know, I state the law. What did the law state? Kechhoff voltage law. The algebraic, look at the word. The algebraic sum of what? Voltage at what? A closed path. And what more of closed path? Now, right. A closed path, right? A closed path. A closed path is a direction or a path that starts and ends at the same point. A closed path is a direction or a path. You can use the word direction or you call it a path that starts and ends on the same point. A closed path is a direction or a path that starts and ends on the same point. Now look at the board, please. Sometimes if they don't call it closed path, you can call it what? Mesh. Look at this case carefully. Anytime you are doing Kechhoff law, you will see something like this. They might give you 2, they might give you 3, they might give you 4. This one I won't see 5. So are you with me? Now if I ask you, how many closed paths is here? Let me show you. A closed path is a direction that starts and ends at the same point. When I start from A, I want to end at A. How will I do it? I will say A, B, F, E, A. So you can see that? So you can say A, closed path 1. Let's call it mesh 1. A, what is that? B, F, E, what? A. When I start from here, how will I end up at the same point? B, C, G, F, B. So mesh 2, B, C, G, F, B. Can we go for C now? C, D, S, G, C. Let's call that mesh 3. C, D, H, G, C. So I'll ask a question now. How many closed paths is here? 3. There's 1, there's 2, and there's what? 3. A, B, C, D. Now, the reason why we're having a closed path is because, now let's assume probably a current, like, let's assume a current I1 is moving like this. I'm just assuming. When the current is moving in the up direction, it goes this way. When it got to what happened? It will split. It's not going to go straight and say, okay, let me come back and meet the same amount of current. No. Because when it got to the junction, it split. Some come here. Those some that come here, we can call that I2. Why those one that go there, we call it what? I3. So this I3 is still going on. When I3 got here also, what happened? Split. The one that comes down will be I4. The one that goes there will be what? Will it split here? Very good. So that's why we have to have a closed path.
What is coming from
It's still going to split. Because at every junction, there will be a split of current and voltage. So let's move on. Now, where am I going to is that so we call this 3, we call this what? 1. At every closed path, you must learn how to form your loop. Hello? I can form my loop in this way. I can form my loop in this way. I can form it this way. It's either you form your loop anti-clockwise or what? Clockwise. And I do tell students, if you go anti-clockwise, if you go clockwise, it does not mean anything. You're still going to arrive at the same answer. But to avoid confusion, I like using one direction because you're going to be dealing with many circuits. So to avoid that confusion, I would advise you that you what? Use one direction. It's either go clockwise, 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 or anti-clockwise, anti-clockwise, anti-clockwise. If you should go clockwise, anti-clockwise, clockwise, you are still good. You are still going to arrive at the same answer. But to avoid confusion, I advise that we should just use one direction. Is that clear? So we can use, for my own case, for my own learning, we are going to be using this clockwise all through my teaching. So is there any questions so far before we start solving question? Okay. Yes. You form the loop. And then you follow the loop. But in case you couldn't find any loop, ensure you create your own loop yourself. So let's start, please. Let's solve the question in the past question. Cut off time.